Okay, good morning. So today we're looking at algebra. We're looking at addition and subtraction equations. So reviewing the last couple classes. I've got 3 examples on the boards here. I'm trying to give you a couple of trickier ones, but just basically reviewing addition and subtraction, okay? In general, people find fractions a bit tricky, so we've got a couple of those as well. So here we're looking to isolate p. We want to get p by itself. How do we get p by itself? Well, I'm going to draw myself that little balance scale to show that those two sides of the equation are equal, right? And then we're looking to get p alone. So how do we get p alone on that side of the equal sign? That's right. We have to get rid of this guy, that minus 3.1. Okay? To get rid of a negative, which is what it is, not minus, a negative 3.1, we have to do the inverse of that. Instead of having a negative 3.1 added to that side, we're going to be getting rid of it. So we're going to add a 3.1. So I'm going to add 3.1 to this side, right? Adding a negative is the same as subtraction, so I'm adding a 3.1 to get rid of it. Now, if I add 3.1 apples to this side, the scale gets to be heavy on that side. So I have to add 3.1 apples to both sides to balance it out. So we'll add 3.1 apples over here. Okay. Then I want to cancel where I can. So I'm going to cancel out 3.1 apples minus 3.1 apples. Well, that gives me 0. Right? And I like to rewrite things so that I can see what I have in front of me. P is equal to negative 4.2, right? This is 0. So P equals negative 4.2 plus 3.1. That's what I actually have to then calculate. Once I rewrite it, I want to calculate what I have. And this is just basically number line stuff, right? So if that's 0, can you even see that? Maybe you can. So if that's 0 there, you're going backward 4.2 steps. And then you're going to go forward 3.1 steps, which keeps you on the negative side, right? So my answer there turns out to be negative. It's a negative value. And then 4.2 minus 3.1 is 1.1. So I've got negative 1.1 as my answer there. Okay? So that's one example. The other example here clearly involves fractions. So I've got negative 1/2 equals z minus a negative 3/4. I did that on purpose because that's one of the subtraction questions, right? Where you have subtracting a negative. Right here is subtracting a negative. I encourage you to think about this as subtracting debt from someone. If you're taking away debt from someone, it's the same thing as giving them money, right? So subtracting a negative is the same as adding a positive, right? So z plus 3/4. Okay, is what I have there. Now I want to get z alone on that side of the equal sign, right? So to isolate z, I'm again going to at least think about this in terms of a scale, right? Sometimes you can just draw a line at the equal sign and that's enough, right? Just to clearly separate those two sides of the equation. Basically, I have z plus 3/4. I want to get rid of the 3/4, leaving z alone. Okay? It's currently adding 3/4. So to get rid of an adding 3/4, we need to subtract 3/4. If I subtract 3/4 from this side, I have to subtract 3/4 from that side as well. Okay? Cancel where I can. And then I like to rewrite things. Okay? So I've got z is equal to negative 1/2 minus 3/4. Okay. Now, I don't really care how you deal with negatives. Clearly, we're going more and more negative here. But what I've encouraged you to do is think about subtracting a positive, right? Subtracting a positive is the same thing as adding a negative. Okay, so we're just getting more and more negative here. We're going left all the time. Okay, but these are fractions, so we need to first find that lowest common denominator. Well, between 2 and 4, I think that we can see the lowest common denominator is going to be 4. And we need to express both of those numbers over 4. Right? So we multiplied the 2 by 2 to get 4. That means you have to multiply the top by 2 as well. And negative 1 times 2 is negative 2. 4 times 1 is 4. So negative 3 times 1 is negative 3. Okay? And then because they're both going in the negative direction, I've got, they add together. So I have a negative 5 over 4. The denominator stays the same. And that's the answer to that question. Okay? My head's in the corner. Hello! Okay, and then we'll do this last one over here. Okay, I think we can see that one as well. So this is maybe the harder of the questions in terms of fractions, right? We have mixed numbers here, in fact. But I'm still going to work to isolate the variable first, okay? Just so you always get in that habit. And again, if you don't want to draw a scale all over the every time, just separating that equal sign so you can clearly see the two different sides of the equation is important, okay? So I like to draw at least a line there so I can see that. I want to get x by itself, right? In order to get x by itself here, we need to move the guy bothering the x, right? So we're going to move this guy. It's currently a plus 2 1/3. So to get rid of it, we're going to subtract 2 1/3, right? So we'll subtract 2 1/3 from both sides. Cancel where we can. And when I rewrite this, I usually like to write the variable on the left-hand side, but it doesn't matter. X equals this stuff, right? So negative 3 3/4 minus 2 1/3. Okay? So we just isolated the variable. X equals something. Now we have to calculate this mess. And so I've taught you anyhow, when you're dealing with fractions, that you want to first express these mixed numbers, right, into improper fractions. That's the first step. So the bottom, right, the denominator times the whole number, and then you're adding the top. And we're just going to make sure we keep this guy as a negative. So 4 times 3 is equal to 12. 12 plus 3 is 15. So negative 15 over 4. Okay. We'll do the same thing with the other guy here. 3 times 2 plus 1. So 3 times 2 is 6. 3 times 2 is 6. Plus 1 is 7. So negative 7 over 3. Okay. So now we have these guys expressed as fractions. Now we just need to deal with adding them, right? So our lowest common denominator, between 4 and 3, you can check it out, right? You can use a little times table system or whatever method you like, but maybe you can see that 4 can be divided into 12, as can 3. 3 can also be divided into 12. So 12 ends up being our lowest common denominator. Okay, blink, blink. We'll accept that, and we're going to put this over 12, and we're going to put that over 12, right? With the subtraction in the middle. So 4 times 3, 4 times 3 is 12. So if I'm multiplying the bottom by 3, I also need to multiply the top by 3 as well, right? So negative 15 times 3 is negative 45. 3 times 4 is 12, right? So I'm multiplying the bottom by 4, so I'm also going to be multiplying the top by 4 as well. Negative 7 times, or 7 times 4, I guess, if I leave the subtraction there. 7 times 4 is 28. Okay? So now I've got the same denominator, and I can more or less do this mathematics now. As I told you before, subtracting a positive is the same thing as adding a negative. And I encourage you to think of it that way, which means you're just going to the left more and more, right? Your final answer is going to end up being a bigger negative. 45 plus 28 is 65/73 over 12. And that's a fine answer for me. As a reduced improper fraction, that's completely kosher. If you wanted to change it to a mixed number, whatever floats your boat, right? The answer keys might express answers in mixed numbers sometimes. So you want to be thinking about 12 goes into 73, I believe it's 6 times, and then there's going to be 1 left over. So you can express it as a mixed number if you'd like, or you can leave it as a reduced improper fraction. Okay, so thank you very much for watching. This is one of my longer videos, I guess, but these examples are getting a bit longer. The next video will be about multiplying equations, and I hope you enjoy that as much. Thank you very much. Bye for now.